Finally, we have landed up with the talk of the topic of the talk, which is very important, which is storage and sharing. It's good that we have reached the stage, step 4, after going through a lot of tedious process of collection, pre-processing, annotations. But now the point comes how to store, to store the data and how to share the data among others, and use it efficiently to train better models, right? So now for storage, let's go step by step with the process. So for the storage, we have, based on the storage, we have different types of machine learning. First one is centralized ML. Second, we have the opposite, decentralized ML. And third, we have distributed ML. So when I say centralized ML, all data is stored and processed at a central location or a single server, or at a single cloud server, you can also say, which is responsible for collection, aggregation, training, and everything. So all the general machine learning is also called a traditional machine learning, is of centralized machine learning. So where we data is stored at a single server, and all the processing happens from the data stored at that server. So here, let us go step by step. So in centralized ML, there will be a centralized cloud server, let's say, or server, and all the data collection parties or the clients, let's say I call them clients, or users, or the parties who collect the data, will store the data at that server. And here, after storing the data in a centralized location, it is responsible for collection and model training and testing, right? So there will be a model here, machine learning model, and then the model will be trained using the data collected from different entities in a centralized location. So this is a centralized ML. And decentralized ML, it's a quite opposite. So decentralized ML, so it's also called peer-to-peer ML. So here we train ML models across multiple nodes or the devices or the users or the parties, each holding a portion of the data. So the same example, let's say C1, C2, and C3. So, sorry. So each holding their respective data, they try to share the data and balance the load, and every entity or is responsible for training ML models and across themselves, and based on the portion of data they have. So here the clients share resources directly with each other without the need for any centralized entity or server. So it's called decentralized, ML. So next we have the distributed ML, which is kind of upgrade to the you know decentralized ML. Here we have server, again the clients or the devices or the users. Here the server definitely collects the data, but it again tries to redistribute the data. So the server collects user data and redistribute them to other computational nodes, basically to exploit the computational resources and doing the load balancing. So that's where the distributed ML setup is important, where to balance the load. For example, C1 has good amount of resources that can handle both C2 and C3 data as well, but they don't talk to each other. The centralized entity here will try to share the resources accordingly to exploit the computational resources of C1, and then doing the load balancing. So basically that is how storage, based on the storage we have different types of machine learning available. And next we'll move on to the sharing part. Sharing or data sharing. So in the sharing step, the main and the primary challenge is the privacy. So when I say privacy, so all data cannot be shared. Any data sensitive that carries sensitive information cannot be shared, because it holds the private information of the user. For example, in applications like medical domain, the patient's data is very private. What kind of diseases or health diseases, or whether or not he has diagnosis with certain kind of cancer, all this information, his age, his health condition, all this information is very much private and cannot be shared with other people in healthcare. Second, in banking sector, the person's credit score, or all the banking information is very private. And in defense applications, a country's defense is very information is very much private, cannot be leaked to other countries, which can easily exploit the vulnerabilities of the country's defense, and they can easily try to attack, and there can be drastic consequences. So all that data carries sensitive information, and it is very important to um, consider that they are they cannot be shared between the entities, and we have to safeguard the privacy of the data. Now there are certain rules which are like GDPR, just general data protection regulation, which tries to set the rules to safeguard the privacy of the personal data. By it's from the European Union. So it tries to safeguard what kind of information can be shared between the between the users, and what how data can be privatized, and what kind of information can be shareable, and what type of information is, has to be safeguarded. So why I'm discussing all this information about sharing and privacy and things like that, because we have done the entire tedious process of collection, pre-processing, annotation, and we are trying to store them in a centralized location, but in a decentralized and distributed, the data sharing happens, right? So when the sharing comes, that is the bottleneck of what all we have done. So if there is no data and we are only sorry, if there is no sharing and we are only keeping it at one place, then the models, how can we train the models which are located at a different places, right? So basically what I want to conclude here is, let's say, on one side we have the data we have prepared, rich data which follows all that above mentioned properties and overcomes the challenges, and we have successfully pre-processed, annotated the data, and pre-processed, sorry, annotated and denoised and collected large amount of balanced data, right? On another side, we have the model centric AI approach models, model centric AI models, or state of the art models, which are giving better and better accuracy on publicly available data sets, and they really want to explore the applicability of their models on real world data sets, like medical, defense, and banking real world data set they want to explore. But the now the model again the model requires huge amounts of rich data, which is a requirement, and the more the good data is better is the model. So one side we have good amount of data ready to be shared, and another side we have good amount of models ready to be applied on that data, and for the betterment of the models. But in between we have privacy, which is a bottleneck, and that's why people are now focusing on something called, we have to, and we cannot overthrow machine learning and what all it has been done till now and it can do in the future. So we need machine learning and AI in our in developing more better models and accurate models, and at the same time we want to safeguard the privacy.